Okay, let's jump right in. What if I told you that our entire universe, and I mean everything, stars, galaxies, even all the quantum weirdness, isn't built on physics at all? What if it all comes from a single, super simple rule of logic? Yeah, that's the wild idea we're digging into today. So I want you to forget everything you think you know about reality. We are starting from absolute zero. Ah, yes. E equals mc squared. You've seen it a million times, right? It's probably the most famous equation on the planet. It connects energy, mass, and the speed of light. And we're all taught that this is just a fundamental fact of how the universe works. But what if it's not a fact? What if it's actually a clue pointing to something much, much deeper? And that's the real question we need to ask. Why this equation? Why does energy have to equal mass times the speed of light squared? I mean, sure, we can measure it, we can prove it works in our experiments, but what's the deep down reason it has to be true? What's the principle that forces it into existence? Well, get ready, because the answer is probably not what you're expecting. See, the framework we're exploring today suggests something, well, pretty astonishing. It says you don't need physics to derive this equation. You don't need to assume space exists, or time, or particles. Nope. All you need is one single, simple rule of logic. A rule that just defines what it means for anything to be considered real in the first place. So here we go. This is the core idea. This entire way of thinking is built from just one foundational principle, one axiom. It's called HAOS. It sounds complicated, I know, but it's really just a fancy way of saying, for something to exist, its story has to make sense, and it has to be able to survive. That's it. This one rule, it's the bedrock for literally everything else. So how does this rule actually work? It's pretty simple, really. For anything to be considered real, it just has to be able to survive an interaction. Think about it this way. If you push something and it just completely disintegrates, it can't pull itself back together, well then it kind of stops existing in any meaningful way, right? To be real is to be able to persist. That's the one and only rule we're using as our starting point. And just as important is what we're not starting with. I want you to really let this sink in. No space, no time, no particles, no fields. We are throwing out everything we usually take for granted about the universe. The only things we're allowing ourselves are these three little concepts: interaction, being pushed around a bit, or perturbed, and the ability to recover. From just these logical pieces, we're going to see if we can build a whole universe. It's wild. Let's see how it works. Okay, first up, energy. What is it? In this new picture, energy isn't some mystical stuff floating around. It's just a functional requirement. It's the cost of recovery. Simple as that. If a system gets pushed, it needs some capacity to pull itself back together, right? Well, that capacity, that's energy. If you have no capacity, you can't recover. And if you can't recover, you're not real. So then, what about mass? Again, let's forget our old ideas of matter or stuff. In this model, mass is just a measure of a pattern's persistence. You could call it the inertia of its own coherence. A high-mass system is one that really, really resists changing its structure when you push it, but it can still recover. A low-mass system, well, that one is much easier to reconfigure. And this naturally brings us to c, what we usually call the speed of light. But here, it's so much more than that. It's not just about light. It's a fundamental speed limit on reality itself. Think about it for a second. If a system could recover from a push instantly, cause and effect would just break. There'd be no before and after. So for reality to have a sensible sequence, a history, that recovery process cannot be instantaneous. There has to be a cosmic speed limit, and that's c. And just like that, here we are, right back where we started. When you put these logical definitions together, E equals mc squared stops being just some random physical law. It becomes a logical necessity. It has to be true. The energy needed to recover a system, E, must be proportional to how much it resists changing, its mass, m. And that cost scales with the cosmic speed limit of recovery, c squared. Now, you might ask, why squared? Well, it's because it has to account for both the speed and the scope of that recovery. So this famous equation, it's not really physics. It's more like the fundamental economics of what it takes to exist. All right, so that one single rule gives us mass and energy. Pretty cool, right? But it doesn't stop there, not even close. The very same logic of survival and recovery, it also forces other even bigger concepts into existence. I'm talking about things like time, entropy, and, yep, even gravity. So what is time in this system? Well, it's not some fourth dimension we're all traveling through. Nope, it's much simpler. It's just the sequence of events. First, a system gets perturbed. Then it recovers. That little word, then, that's what creates time. And because every recovery always has a cost, that sequence can't be undone. It's irreversible. So the arrow of time, you could think of it as the universe's ever-growing, one-way accounting ledger of all its repairs. And this leads us straight to a completely new way of thinking about entropy. We're always told it's about disorder, like a messy room. Forget that. In this view, entropy is recovery debt. It's an accumulated debt. Every single time a system recovers, it pays a tiny cost. And that payment, it limits its future options. So the constant increase of entropy isn't a march towards chaos. It's the slow, steady closing of doors. It's the shrinking of possible futures as the universe pays its ongoing bill just to stay coherent. And gravity? Get this. It's not a force that pulls things down. It's a bias. Systems, or maybe more accurately their histories, are always going to naturally follow the paths that are cheaper, the ones with the lowest recovery cost. They flow towards configurations that are more stable, the ones that are easier to maintain. So objects don't fall. Their histories are just being channeled towards the path of least resistance, the easiest way to stay real.
Okay, let's pause for a second. This framework seems to rebuild our entire everyday classical world just from logic, which is pretty impressive, right? But here's where it gets truly, truly mind-bending. The same exact rule, that one rule of survival, it also seems to explain the bizarre, completely counterintuitive world of quantum mechanics.
I mean, quantum mechanics is famous for all its weirdness, isn't it? You've got superposition, uncertainty, that mysterious collapse of the wave function. It feels like it makes no sense. So how on earth could a simple rule about recovery possibly explain all that? All right, let's start with that famous wave function. What is it? This framework argues it's not a physical wave at all. It's just a special kind of bookkeeping. It's the tool, the math you need, when a system is juggling multiple potential futures at the same time. Futures that can overlap and interfere and even cancel each other out. It's basically just a map of all the possibilities. Okay, so then what about the infamous collapse that happens when we measure something? Well, according to this idea, nothing is physically collapsing. No way. Instead, it's the bookkeeping system itself that crashes. The super complex interference-based map just becomes too costly to maintain, so the system defaults to a much simpler description. So here's how that crash works. Down at the quantum level, the system is busy tracking this incredibly rich, complicated web of possibilities, and they're all interfering with each other. But as that system interacts more and more with its environment, keeping that complex map up to date becomes too expensive. It starts to exceed the system's budget for recovery. So what does it do? To save resources, it just defaults to a much simpler single outcome description. It drops all the messy, complex details. See? This isn't some kind of quantum magic. It's just a logical strategy. It's resource management. And all of this brings us to the final and maybe the most profound conclusion of this entire framework. It forces us to completely rethink what it even means to measure something, and ultimately what it means for anything to exist at all. And here it is. This is the big payoff. A measurement isn't some magical act that forces reality to choose one state over another. It's just the breaking point. It's the moment where that complex quantum way of describing things becomes unsustainable. The single outcome that we end up seeing, that's simply what's left over after the more complicated, more expensive description fails. So, what does this all mean? What's the big takeaway here? It's that the laws of physics, they might not be arbitrary rules at all. They might just be the inevitable, logical consequences for any system that can manage to survive being pushed around. Familiar things like space and time and mass, they aren't the fundamental building blocks of reality. They're more like useful summaries, compressions of this deeper logic. And that means the weird quantum world and our familiar classical world, they're not separate realities. They're just two different representational regimes, two different languages that reality uses to describe itself, depending on the circumstances. And that leaves us with one final, truly mind-bending question to chew on. If this whole framework is even remotely on the right track, then we haven't really discovered the laws of physics. Not really. What we've done is simply recognize the logical constraints that any persistent reality has to obey. So, what are we? Are we explorers mapping out some strange and mysterious land? Or are we just logicians slowly figuring out the only possible way the game could ever have been played?